Research Journal, Entry 1. I'm about to embark on one of the great challenges of my scientific career. Teaching Penny physics. I'm calling it Project Gorilla.
Hey, Sheldon.
Come in. Take a seat. Subject has arrived. I've extended a friendly, casual greeting.
Ready to get started?
One moment. Subject appears well rested and enthusiastic. Apparently, ignorance is bliss. All right, let us begin. Where's your notebook?
I don't have one.
Well, how are you going to take notes without a notebook?
I have to take notes?
Well, how else are you going to study for the tests?
Is there gonna be a test?
Tests. Here. That's college ruled. I hope that's not too intimidating.
Thank you.
You're welcome. Now, introduction to physics. What is physics? Physics comes from the ancient Greek word physika. It's at this point that you'll want to start taking notes. Physika means the science of natural things, and it is there in ancient Greece that our story begins.
Ancient Greece?
Hush, if you have questions, raise your hand. It's a warm summer evening, circa 600 BC. You've finished your shopping at the local market, or agora. And you look up at the night sky, and there, you notice some of the stars seem to move, so you name them Planetes, or Wanderer. Yes, Penny?
Does this have anything to do with Leonard's work?
This is the beginning of a 2,600-year journey we're going to take together from the ancient Greeks, through Isaac Newton, to Niels Bohr, to Erwin Schrödinger, to the Dutch researchers that Leonard is currently ripping off.
2,600 years?
Yeah, give or take. As I was saying, it's a warm summer evening in ancient Greece. Yes, Penny?
I have to go to the bathroom.
What? Can't you hold it?
Not for 2,600 years.
Project Gorilla, Entry 2. I am exhausted. Now remember, Newton realized that Aristotle was wrong and force was not necessary to maintain motion. So let's plug in our 9.8 meters per second squared as A, and we get force, Earth gravity, equals mass times 9.8 meters per second. So we can see that MA equals mg, and what do we know from this?
We know that Newton was a really smart cookie. Oh, is that where Fig Newtons come from?
No, Fig Newtons are named after a small town in Massachusetts. Well, don't write that down. Now, if MA equals mg, what does that imply?
I don't know.
But how can you not know? I just told you. Have you suffered a recent blow to the head?
Hey, you don't have to be so mean.
I'm sorry. Have you suffered a recent blow to the head?
No, you just suck at teaching.
Really? Of those two explanations, which one seems the most likely?
Sheldon, look, I'm trying to understand, but you're going too fast. Can you just back up a little bit?
All right. It's a warm summer evening in ancient Greece.
Not that far back.
Okay. At what point did you begin to feel lost?
I don't know. Where were we looking up at the night sky?
Greece.
Damn it!
Look, there's no need to get frustrated. People learn at different rates. Unlike objects falling in a vacuum, which... MA equals mg...
Squared?
No.
Aristotle?
No.
5?
Oh.
Then I don't know.
Why are you crying?
Because I
Well, that's no reason to cry. One cries because one is sad. For example, I cry because others are stupid and it makes me sad.
Okay, look, can we just please forget about all this extra stuff and can you just tell me what Leonard does?
All right. Leonard is attempting to learn why subatomic particles move the way they do.
Really? That's it? Well, that doesn't sound so complicated.
It's not. That's why Leonard does it.
Okay, I just have one question. What exactly are subatomic particles?
A good question.
Thank you.
And to answer it, we first must ask ourselves, what is physics?
Oh, balls.
It's a warm summer evening in ancient Greece.
Raj, you should have seen Leonard's experiment. The interference pattern was so cool when the electron beam was on.
I'm glad you enjoyed it. Most people aren't that interested in what I do.
Actually, that's not true, Leonard. In fact, recently I've been thinking that given the parameters of your experiment, the transport of electrons through the aperture of the nanofabricated metal rings is qualitatively no different than the experiment already conducted in the Netherlands. Their observed phase shift in the diffusing electrons inside the metal ring already conclusively demonstrated the electric analog of the Aronoff-Bohm quantum interference effect. That's it. That's all I know. Oh, wait! Fig Newtons were named after a town in Massachusetts, not the scientist.